Crater Lake in southern Oregon is the deepest lake in America. Almost 2,000 feet of water, so clear you can see down over 100 feet. What 500,000 tourists are standing on when they visit the rim is a volcanic crater called a caldera, one of the most dangerous volcanoes in the country. Southern Oregon, 2011. For the first time in history, a volcano science team installs earthquake sensors inside the Crater Lake caldera. 3 stations along the rim and a 4th on Wizard Island, the volcanic cone jutting out of the water near the western shore. The lake sits in one of the most remote national parks in the lower 48 states, buried under snow for most of the year and reachable by road only in summer. Before this, there is no equipment set up to listen to what is happening beneath the deepest lake in America. Nothing. The nearest instruments sit outside the park, kilometers away, built to track earthquake activity across the Cascades, not the specific rumblings of a single volcanic crater. A volcano ranked in the top 18 most dangerous in the United States. And for decades, nobody has instruments close enough to hear it. This decision seemed small at the time. It wasn't. It takes less than 2 years for the network to pick something up. On October 25th, 2013, 3 small volcanic earthquakes show up on the stations. The largest is roughly magnitude 0.8, tiny, barely a whisper. These are not surface quakes caused by shifting plates. They are volcanic earthquakes, created by stress changes in rock near a magma source. The kind of event that would go completely unnoticed without equipment built just for this purpose. The official announcement describes these as the first earthquakes recorded at Crater Lake by the new monitoring network. That wording, by the new monitoring network, is doing critical work. It means these are the first quakes picked up by the new equipment, not the first quakes ever. Earthquakes near Crater Lake have been recorded since at least 1920, when a roughly magnitude 4 event shook the area. In 1947, a magnitude 3.7 quake struck near Fort Klamath, south of the park. In 1994, 3 quakes between magnitude 2.3 and 2.6 rattled Rim Village, the main visitor area, years before any earthquake sensor sat inside the caldera walls. That difference gets stripped when the headline travels online. First earthquakes ever under the water is what spreads. The wording disappears. So does the date. And the context goes with it. And from there, the story twists into something the science never supported, recycled year after year as if it is breaking news. But the clickbait is not the interesting part of this story. What the instruments actually find beneath that water is. Crater Lake sits at 6,178 feet above sea level in the Cascade Range. The lake fills a caldera roughly 8 by 10 kilometers wide and holds nearly 5 trillion gallons of water. There is no river feeding it, no stream running in or out. Every drop comes from rain and snowmelt, and the lake loses water only through evaporation and slow seepage through volcanic rock. The entire volume replaces itself roughly every 250 years. It is a closed system, sealed by the very geology that created it. The water is cold. Near the surface, temperatures sit around 50 degrees Fahrenheit in summer. Near the bottom, just above freezing, the clarity is staggering. It is measured by lowering a black and white disc called a Secchi disc into the water until it vanishes from sight. The long-term average depth where it disappears is nearly 100 feet. The record is 142 feet, set in 1997. That clarity exists because there is almost nothing living in the upper water to cloud it, which makes what sits at the bottom even harder to explain. In 1988, a small one-person submarine called Deep Rover is lowered to the bottom of Crater Lake. It is the first time anyone has seen the caldera floor with their own eyes. The deepest freshwater setting in the country, sitting in near total darkness under crushing pressure. The expectation is cold, bare, lifeless rock. What they find is the opposite. At nearly 2,000 feet down, in water that should be completely freezing and lifeless, there are hot water vents. Warm, mineral-rich fluid seeps upward through cracks in the volcanic rock of the caldera floor. Bacterial mats, thick clusters of tiny organisms feeding on sulfur and iron, spread across the lake bottom near these outflows, powered not by sunlight but by chemical energy from beneath the Earth's crust. In the south-central basin, there are pools of shimmering water sitting in dips on the floor, warmer and saltier than the lake above them, with visible edges where the pool water meets the surrounding lake water. Fluids loaded with carbon dioxide